Yes. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and a very good afternoon to everyone. So a warm welcome to Mr. Nur Safaruddin bin Kamaruddin, our esteemed speaker, Dr. Afiq Ali, our respected Geoscience Club UMT advisor, for joining us today. Special appreciation to Muhammad Adil Imran, President of Geoscience Club, Lukman, the Program Director, for his effort. And we also extend our gratitude to all participants from UMT, UKM, USM, UMK, and UITM, as well as all distinguished guests and attendees. Your presence truly enriches this occasion.
Tak dengar.
So welcome to...
Audio daripada UMT tak dengar. Saya tak dengar apa-apa.
Tak dengar. AJK lain dengar?
Dengar. Saya dengar je.
Video okey. Saya nampak awak gambar tadi 2-3 video. Tapi audio tak ada. So video awak okey. Saya nampak participants ada 48 participants. Saya nampak ada yang on video, saya nampak video tapi audio awak saya tak dengar.
Yes. Cik Safaruddin boleh dengar? Yes.
Assalamualaikum. Cik Safaruddin boleh dengar?
But on the other hand, saya punya audio awak dengar tak? Dengar kan?
Dengar.
Tapi saya tak dengar awak punya audio. Somebody got to on awak punya microphone tu and then talk to me.
Tak.
Assalamualaikum. Cik Safaruddin
Oh,
boleh dengar ke?
okay. Nak saya start ke? Nak saya start sekarang?
Saya MC Cik Safaruddin.
So ada nak introduction ke apa ke
Ada.
your protocol
Ada
on this
protokol.
apa ni program ni talk ni. So right. speaker saya. Okay, hang on. Maybe. Hang on. Standby one.
Encik Safarudin dah boleh dengar dah?
Speaker saya okay. Cepat. So, saya tak dengar Afiq Najmi, saya tak dengar. So, ada yang somehow, somewhere, is recording in progress, okay. Okay, nak dengar, okay, now. Bagi tahu saya, nak saya continue terus, start dengan presentation ataupun ada protokol yang awak kena start dulu, present introduction lah, apa semua, terima kasih sana, terima kasih sini, thanks sana, thanks sini, then I can start. Or I can start straight away. Yeah.
Mungkin kalau macam tu boleh start je kot. Sebab tak boleh nak dengar kan. Ke Aidil nak buat protokol ke?
Uh, saya rasa kita teruskan dengan protokol dia lah, Doktor.
Protokol. Okay, boleh.
Okay, ideal. Proceed. Saya dan kita dah 15 minit ke depan ni. So you start whatever you have to do. Ini bagi tahu saya, then I can start straight away saya punya presentation.
Okay. Sorry for the inconvenience.
Ideal.
Welcome to GEOTALK 4.0, Coordinate Reference System in
Just go
Geology.
ahead. So kalau yang lain dengar, then it's okay. So I'm okay with that.
So before we begin, let us start with recitation of doa to seek blessing for this session. For that, I would like to invite Muhammad Firdaus bin Zakaria to lead the recitation.
Because saya nampak ni, semua you punya mikrofon ni mute. Semua mute. So, okay. Luqman, talk to me. Luqman pun mute.
Hello.
Okay. Tak dengar.
Hello. Can you hear me?
Strange. I can see you, but I cannot hear you.
So should we start with doa?
Right.
Okay. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Ya Allah, ya Tuhan kami, yang Maha Pemurah lagi Maha Penyayang, kami berhimpun pada hari ini berdoa memohon rahmat dan hidayah darimu. Semoga dengan rahmat itu Engkau berikan petunjuk kepada kami, Engkau perkukuhkan kepaduan kami, Engkau memperbaiki urusan agama dan dunia kami. Ya Allah, ya Tuhan kami yang memiliki segala kekuasaan dan kemuliaan, kurniakanlah taufik dan hidayah-Mu kepada kami, restuilah perancangan kami, bimbinglah kami dengan petunjuk-Mu yang lurus yang berterusan, pimpinlah kami sekalian ke jalan yang lurus dan benar yang membawa kepada ketenteraman dan kesejahteraan. Hindarkanlah kami sekalian dari segala malapetaka dan sifat-sifat yang keji. Selamatkanlah kami sekalian dari perselisihan yang boleh membawa perpecahan dan kebinasaan. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Walhamdulillahi rabbil alamin. Amin ya rabbal alamin.
Amin ya Rabbal Alamin. Ladies and gentlemen, For today's GeoTalk, we are honored to have Mr. Noor Safaruddin bin Kamruddin as our distinguished speaker. Mr. Noor Safaruddin is a seasoned offshore surveying consultant and director of TIS Geoscience Sendirian Berhad with over 30 years of experience in land surveying, offshore hydrographic operations, and oil and gas industry project. He has led various notable positions, including Deputy Chairman of the National Hydrographic Association and has contributed extensively to research and education in hydrography. His expertise spans across hydrographic surveying, geodesy, and offshore construction, making him the perfect speaker for today's topic on coordinate reference system in geology. So, without further ado, let us give a warm virtual welcome to Mr. Noor Safaruddin bin Kamruddin.
Okay, bagi saya cue kalau saya dah boleh start. Message. Alright, masih. Okay, now let me share my presentation. Allow me to do that. Okay. Tell me, can you see this? Can you see my presentation? Audio, video, okay?
Boleh, okay.
Right, good. Let me start. Okay. Assalamualaikum warahmatullahi taala wabarakatuh. Good afternoon to all, and then especially to Dr. Muhammad Afiq bin Muhammad Ali, so your lecturers, and then to all of you, especially to all of you watching and listening to me on Saturday afternoon. And that is not easy to do. Okay, so we're going to have maybe I try to one and a half hour slow presentation to you about this. So you were given the topic about coordinate reference system. I summarize it as CRS in geology and what can go wrong, and then I add offshore. So that will be a very interesting topic because I'm not going to cover land. On land, no issue. If you have a wrong coordinate reference system, you know where you are. But offshore is different thing. Okay, let me go through this now. Right, a little bit of introduction. So my background, I'm a hydrographic surveyor, offshore hydrographic surveyor. I was trained, well, I think 25, maybe 30 years experience. Graduated from UITM Shah Alam on land survey and geometric. Now they call it geomatics, right? Oil and gas and not oil and gas, and land surveying, offshore coastal surveying. So that. And your background, I understand from Luqman, and then I understand from previous talk. I'm not sure when was that. And your background is geology or marine geology, or somehow in the background there's a geology. You're not geometric anyway. It's geology. So now we have one common method, guys. Yeah. So this is what I'm going to dive into, so that you will appreciate it when you graduated and work somewhere, locally, domestic, or internationally. And one common method is location, guys. So this is my objective today in hour and a half. It's not fair to you, and it's not fair to everybody who's listening, that you can understand, that you can emotionally understand about how location matters. Yeah, and the objective for me is to make you aware and a little bit of knowledge But for skill, after that knowledge, skill, you have to do it yourself. At least the terminology. So write down terminology, record the terminology I'm going to share with you. And the importance of CRS, the Coordinate Reference System, right? And mark my keyword, mark my word. Yeah. If I start repeating itself, repeating the word, meaning it's important, right? So location matters, and that is the objective I mentioned to you just now in geology. Yeah. Okay. Because I work with a national oil company and then also international oil company. Surrounded by geologists, geophysicists, petrophysicists, drilling engineers, structure engineers, offshore pipeline engineers, and whatnot, that were not trained to handle location, to handle position, and that's why we come in to fill the gaps. Okay. Right. So I have 5 overviews to share as we go along. It's about offshore. It's about CRS, and then mark that word EPSG and ROGP. Some of you may have come across this terminology, abbreviation, and whatnot. And common misconception and inaccuracy in CRS, right? So, and what went wrong? This is what has happened in previously, right? Then it's happening now if you don't do it right. And then the solution, how are you going to fix it? Okay, these 5 overviews, I'm going to touch a little bit here and there, and then hopefully that you can you can benefit from there. Okay. And Q&A question, either you want to do it in chat box, or you can, if you can, I can hear you, then you can ask. But chat box will be better. I will repeat your question, and then I will answer it, and then hopefully this session is recorded. Yeah, I think it's recorded. You can see that. Right. So guys. So whatever your background is, so we are connected with this location things. Yeah. Geographical coordinates, Greek coordinates, right, and so on. So whether you are geology, you are geologists, you are seismic guys. So in the future you may be working in seismic company, engineering data management, data processor, and then maybe you are the client one day. You are working with a national oil company or international oil company. You're dealing with a lot of data, yeah? So pipeline data, bathymetry, and whatnot. So this is some of it, yeah. It can be 100 types of data. And the common denomination of this data is location. So mark my word until the end of your life. Location is important because that is the only common things with the data. Right? Okay, move on. Now I'm talking about offshore. I'm not talking about land. Land, you know where you are, which country you are, which district, which kampong, which land you're going to be, so you know that, no problem. But this is offshore, guys. The only thing you can see is the moon and the sun and the stars and the horizon like that. And this is another one. This is rough weather. This is calm weather. And then this is worse. Because you're walking at night, you can't see anything. So if you are in Mozambique, or if you are somewhere in Morocco, if you're somewhere in Sunda Sea, or somewhere in Vietnam, South China Sea, or somewhere in Taiwan, this is the same sea that you're going to be. Yeah, only geographical location dictate where are you at the time. So because of this, then you need something, 100% confirm that you are on the right location. Okay, next. And then there's a CRS. CRS are the fundamental to the business. This is something that you have. So CRS, coordinate reference, coordinates. CRS define position you on where you are on the earth. Yeah, even if you go to the moon, so you need position for that on the moon. That is totally different CRS. Okay. And in CRS, let you find your way back to the point, the same point, because each point in offshore for oil and gas or for other purposes offshore, you are going to visit the same point over and over again until the end of the lifespan of that area. So end of a project, finish, no more. So you're not going to go back again. But if you want to go back to the position for some reason, engineering reason, environmental reason, geophysics reason, or some other security reason for the country, we have to do, we have to make sure that we right, we have to make sure the position is correct. Otherwise, you are going to set to the different location, and then you're not going to find any solution, right? And then CRS are legal standards. So anywhere in the world, position is a legal thing. If you drill at the wrong location, somewhere in South China Sea, and then at the end of the day, that you know that that location belongs to Indonesia or belongs to Vietnam, and then sorry to say that, bye-bye. So that position belongs to the country. So you work for free for them, right? And then and so on, equities, legal compliance, and all that. So yeah, I'm not going to stay there, but you'll be there soon. Yeah. So either you are the field geologist, or you are the guy who's going to manage the project, or the owner of the project in many layers. So then what about business? What coordinates this related to business, right? Because everything is business. Even the government fund is a business. Yeah, as long as the commercial involved, there's a business. It's about reliability. It's about integrity of the point. It's about the cost, right? So if you explore at the wrong location, and then then there goes the cost. Reputation. So reputation is another thing. Is if you do it wrong once, maybe people can forget about it. But if you do it wrong twice, or 3 times, or many times, then your reputation, your team reputation, your company reputation will go down the drain. And then repeat order. If you do it right, so the next job is yours. Profit. You make profit, more bonus, more gaji, and then more benefits. And then you can stay longer at the same company, same position, and or maybe enjoy the benefits, and then etc. etc. So that's about business. So it's not, even though we're talking about location, CRS. So now next about CRS, EPSG, and IOGP. What these 3 things related to, yeah. So CRS, abbreviation of coordinate reference system. Okay, if you study CRS, maybe you can study in 1 semester, maybe 2 semesters, with practical and then tests and all that, just to make sure that you understand, because CRS, different country has a different CRS. Ladies and gentlemen, CRS is a lot to offer. So if you are in a degree now, you know, a bachelor degree, first degree, so you can pursue to masters and PhD just on this topic. Yeah. So CRS is geodesy plus applied maths. So if you're good in maths, then this is your game, right? This is your cari makan. Yeah? So geodesy plus applied maths, because I have many friends that started with geology, then masters in applied geodesy, and then PhD in both combined. So geology, geophysics, and then geodesy, and then apply. So if you're by research, then you can pursue for a specific location, for a specific issue or specific case on that topic. Okay. Right. Next, and then learn and understanding geodesy make land and offshore surveyor different from another colleagues. So you have to be good with surveyors, to be honest. Surveyors that understand the geodesy, or you yourself can learn a bit more and then apply to what you understand on the geology. Yeah. Okay. And then there's two types of CRS generally. So I'm talking about basic CRS. Yeah, two types. One is horizontal, and the other one is vertical. So horizontal, you know that horizontal XY, easting, northing, latitude, longitude, right? And then vertical is the height. Okay, height from mean sea level, height from land survey datum, height from lowest astronomical tides, highest astronomical tide. That's vertical. So the vertical refers to a certain datum. Okay. All right, and then there are basically more, but I summarize it. 5 implications using a wrong CRS. If you do it wrong, then you have a distortion in your geospatial data. So geologists like to see all the layers of geology, right? You rotate it 360, and then you see some good traces from seismic, some good traces from geotechnical and things like that. But if you have a wrong CRS, so the next time you come back, you'll be in different area, different position. It's distorted. And then when you map it now in a 5 years time, somebody else come back and then say, hey, what's wrong with this location? So and who's wrong, who's right then? Because mapping in the doubt, so you don't have accurate mapping, and when you go back to the same location for further study, further investigation, and then you are the wrong location. Misalignment, yeah, with other data sources. Remember I said there's 100 data types. So geology, one single point have a layer of information there. Property information, the water quality information, the same point, but water quality information during in the morning, different sound velocity, in salinity, different thing. So everybody need to know, everybody need this information, layers and layers of information from a single point. And then difficulty in spatial analysis. So when you have this information, you got this position scattered around. You cannot not say compile, but you cannot conclude it because your data is scattered. So you have a big uncertainty of position that you can't conclude what's going on with the area. All right? Well, is our land move or our ocean move, something like that? Yeah. Right, then communication and collaboration issues. So everybody surveying, everybody measuring same thing over and over again over years, over the time. So that is the fourth dimension. So X, Y, Z. So X, Y, Z, horizontal, and then vertical, and then another dimension is time. So you wants to analyze all these things, and then because of this wrong CRS, then there will be it will involve a lot of mis not say miscommunication and collaboration issues. Okay, so right, next a little bit on see guys, you are mapping. When we talk about map, we map it on a piece of paper, but our earth, what you're going to map is basically not flat. It's a spherical. It's not spherical actually. It's a geoid. It's a very irregular shape of the earth. You know, it's not circle like this. It's very irregular. And then you learn about the magnetic field. You learn about the electromagnetic field, and you learn about other geology characteristic of our Earth. Yeah, so gravity, for example. How are you going to map it into that piece of paper? So that's where this coordinate reference system, the X, Y, and Z, and maybe the time, have to be clearly defined from the start until the end. Right, that's touch of it, but horizontal is about datum. So you can write it down. This horizontal CRS is about datum, ellipsoid, projection, and unit of measure. So unit of measure is about meters, kilometers, inches, feet, something like that, in the projection. And so write it down and then explore. So I'm not going to share with you each and every of these four, but horizontal CRS is about datum, ellipsoid, projection, and unit of measure. So go and find it yourself at EPSG. So write this link, website link, write it down, and then go and explore. So it's fun to explore because EPSG.io offer you online computation utilities. Yeah. All right. So what is EPSG? EPSG, this is, I just summarize it. I just recap it because it's there. It's in the website. Only thing is, if you add a little bit to your geology curriculum, maybe you have this already. I'm not sure. I don't know your content, your syllabus of program content. But EPSG is about European Parent. This is a group, yeah. So this group compile all the CRS in the world, anywhere in the world, right? And then they combine with IOGP. So go and browse yourself, go and understand this, because if you understand this, so during your interview, during your work interview, once you submit your CV, they like you because you have 4 flat score. And then if you know a little bit about this IOGP and then EPSG, so you are one step higher than the rest who doesn't know. And then you have the chance to grab the position, inshallah. Right, and PSG refers to standard method used to identify coordinate reference system. So go to their website and then appreciate what they have done to the community of geology, geophysicists, maritime, non-maritime, and then rocket scientists, or the what do you call it? Satellite mapping, photogrammetry, and whatnot. Okay. So each CRS assign a unique EPSG code. Remember that. So let me tell you now, I'm telling you in advance now, basically. If your friend, now, from now on, if your friend, your lecturers, your client, or your whoever you deal with, provide you a set of coordinate, latitude, longitude, easting, northing, without EPSG code, reject it. I repeat, reject it, right? Because it's no good. Okay, it's no good at all because there's no evidence where that coordinate come from. Reject it and ask what is the EPSG code. Then you can start to do whatever you have to do. And then this code is widely used in GIS and all that. So if your GIS friends, if your future employer provide you coordinates without EPSG, reject it and ask for that. Ask for the EPSG code. Okay, this is the screenshot of the EPSG. I'm going to, it's about 3.5 minutes. So if you can you hear this? Can you hear this? This is the EPSG. Thumbs up if you can hear. I will web. So that guys, if you can hear just now, please say okay because I can't hear you. Okay. All right. This is the PSG.io web, so that you can use to compute on your country, or if you know the code, the PSG code, then you can write down here in the search and the name of the coordinate system. So let's say I'm Malaysia. So there you go. So you got Malaysian CLS in chain, meter, RSO, PRSO, including the state, each state grid. And then you can go to the next image here. So you have RSO Sarawak LSD. So if you want to transform coordinate, for example, like this one, there's a lot of coordinate reference system project geodesy, so it's free for you to use, but you must know how to use it. So the area of, for example, in this one, the area of use is Malaysia and Kedah and Perlis. So for example, like this Sarawak, so you can, you can load this in Sarawak, then you can see the metadata of that, of this EPSG, of this area, of this particular CRS, EPSG 29874. Okay, so as I said, there are many CRS just for Malaysia and any other country as well. So we can use this to compute and then and have a look. Try with your data example and then see if we can get the result based on the data example. There's another one. This is free to use. Okay. There's a lot of other information behind this. So the parameters, the geometric parameters behind this is also published here. So you can see TBAL 1948 and in the average, all the metadata, the birth certificate of this particular CRS. Yeah. So one of it. So you can browse and let's say if you want to go to Thailand, you search for Thailand, and you can see a lot of other CRS as well, just for Thailand. Yeah. So according to the zone, UTM zone, and then whatnot. All right, so this is this particular website, web services utility that you can use compute the particular convert more to project this particular CRS. Right. Done with that. Now, next is about EPSG, geodetic parameter data set. So this another EPSG. This is the home, the home one. Hang on. Oh no, I'm not going to go there. But yeah, that one. So this is the geo repository of all EPSG data set that you want to know. And then just for information, since we are here, this company here, this geometric solution, if you go to the website, this geometric solution here is a local company. They're based in Malaysia, they're based in Kuala Lumpur. So you guys can have a trip or education trip or, you know, a visit to this company and then learn about what they are doing. So basically, I have something for you then, later, but not now, later, about that geometric solution. So I think one of your seniors working there now. So then IOGP geometric. So this is another one. This is for engineering geometrics. So yeah, then you can. Right, and this website is about IOGP, the EPSG, and the IOGP. So it's more than you can chew, more than you can read here about geomatics, yeah. So about coordinate reference and then EPSG as well here. And then you have geodesy here, geoinfo, remote sensing, and all, yeah, surveying, positioning, publication, and also EPSG. It's also under IOGP. Right, so you can browse. In your time, I'm not going to stay this longer. Let's say if you go to EPSG and then you can go to the EPSG parameter data set. Yeah. So geodetic parameters again. So a lot of information about that. And yeah. So if you go here, right, so next, I'm going to next. Okay, next, this is another talk about 7.5 minutes about CRS by these two Americans. So stay with me for.
Hello, my name is Joe Sass. Hi, I'm Phil Stevenson. Today, I'd like to talk about some of the contents on an OPUS report. There is something called WGS 84. There's something called ITRF, and there's something called NAD 83, and the NAD 83 on this report has NAD 83, Cores 96, Epoch 2002. Phil, I think this is a topic that a lot of people don't understand, and I would just like to simplify it a bit and ask you a few questions about this. Do you mind?
Sounds good to me. It's a very confusing issue.
Okay, so let's start out with WGS 84. What is WGS 84?
WGS 84 is an ellipsoid and a datum that's used by the Department of Defense of the United States. It's strictly a DoD system.
So I heard you, I hope the audience caught this. Not only is WGS 84 an ellipsoid, but it's a datum.
Yes. And when we refer to it as a datum, we have to understand that it has iterations in the same way that NAD 83 has iterations. There are various versions of WGS 84.
So let's segue over to this comment I made on this data sheet. It says NAD 83, Cores 96, Epoch 2002. Walk me
Yes.
through that.
Well,
So first off, how does NAD83, do I need all of those parameters to relate NAD83 to WGS84?
well, there's a critical part of this that you just left out, because we really don't have a good way to relate WGS84 to anything, mostly because the Department of Defense does not share that.
Ah.
So how can we relate it? We can relate it to the civilian version of WGS84. What we know is that they're a very close approximation between the current version of WGS84 and the current version of ITRF-00.
So let me stop you. ITRF,
Yes.
whatever iteration it is, it's 00 right now we're talking about, that's civilian.
Yes, that
And
is the civilian version.
WGS84 is military.
You got it.
Okay,
The
all right.
WGS84 is strictly a military system. The ITRF, whether it's 00 or whatever, is sort of the civilian.
Right, I have to stop there. It takes 7.5 minutes, so I don't want to waste all that because we already late 15 minutes just now. If you want this, I'm going to share this with you. Don't worry, guys. I'm going to share this with you through whoever deal with me. I think Lokman. Yeah, so I'll share this with you. Not to worry. All right, so then that's what this is another one I want to share with earlier I said what went wrong. So what went wrong, this you must know, yeah. So this is published. I'm just cut and paste because they published the journal. They published in the journal long time ago, and based on the compilation of all the errors related to CRS. So I'm just cut and paste, and then this document I can share with you. If you ask, you write it down. If you want it, if you want the journal, the write up, let me know, and I'll share with you. Else, you can see here. See, it's all about errors that you cannot accept it. If your errors is about 20-30 meters offshore, that can be accepted, yeah. But if kilometers of errors, because you are in the middle of the ocean, offshore, 30 kilometers, you can't feel it. You don't know. You are away from that far because you're in the middle of the ocean. 900 meters, yeah, mismatch. And then in West Siberia, 200. So all these errors is published, is happening. It's not made up. I didn't make this up. This is being published, yeah. So all these errors, I'll show it to you. This is one of the many things that oil and gas try to avoid. If errors, you can fix it, okay, but if errors involve in fatality like this in Nigeria in 1985, even it happens here somewhere in South China Sea in our waters. The only thing is we do not report or record it and publish it to the public. But this is what happened. You remember the movie, the Deepwater Horizon, guys? Yeah, the Deepwater Horizon, basically, they drill at the wrong location. They drill at the wrong location and they don't know there's a very high pressure underneath. And then, kaboom. Right? Fatality, money. Not just money, but reputation and life and whatnot. Okay, then no incident, but systematic problem. So there's no incident, meaning no asset incident, no asset damage, but they are somewhere in the wrong location. They have to readjust it, and then they have to pay a lot of money for that. So that basically, and then during appraisal well. So during the study, during the initial stage of drilling, and you guys will be somehow interpreting the seismic data sets, and then you're not aware that the CRS is wrong, and then you start interpreting, and the data look, the geology very very nice, very good, very promising, guys, but at the wrong location, right? So the impact resources spent investigating errors, money, expensive reprocessing, and time and money, and not only fair and whatnot. Okay, and then jackup rig drilling the wrong location, and then cost a lot. So what I'm going to you can read this. You can read this later on. The only thing is, it's happening at the moment. We try to minimize it as much as possible by understanding the CRS, by understanding the coordinates, yeah, and then and land-based drilling. So somewhere inadequate or not say not understanding the geodesy, guys, go and learn geodesy. Wrong CRS adopted, and then the position is, coordinate on your paper, on your log, on your drilling log, on your geology log. On paper looks nice, but on the ground is wrong. And then drilling and so on and so on. So I just start. I continue, and I start to feel headache already looking at this. Yeah. So don't do that. If you don't have the EPSG code with your coordinates, reject it. Get the EPSG code, then you proceed with the next one. Whether or not the geology looks beautiful, look promising, but the coordinate is wrong, coordinate is no EPSG with that, reject it. Get correct EPSG code. Okay, and so on, and data conversion. So see, from sequence, from start until the data conversion, one of you or some of you may be working at the data company, geology data company, so on later on. So you can do, if you find something interesting, you can do your master's, your PhD with it. So if you do it right, if you go back to the location, the correct location, then there will be a good discovery, inshallah. So it's about errors, yeah. Right. So yeah, I'm just keep on showing you what the error going to be, 100 meters, horizontal error, height errors. You can be at the right good horizontal location, but if your height is wrong, you may stop at the wrong time before you reach the target, because your vertical is wrong. Yeah, or you drill exceed the actual target because of your height is wrong, and then it costs you more than it's supposed to be. Yeah, so you have enough drill pipes, so you have enough certain tools to go, but since your vertical is wrong and you got the wrong information, wrong map projection and whatnot, so I'm not going to say. I'll just show you what made the errors is incorrect datum. As I mentioned to you, datum, ellipsoid, benchmark and whatnot just now. Yeah, incorrect transformation, datum transformation. Datum transformation you apply twice because there's no record about it. There's no checking about it. And then geologist A say that, oh, there's no EPSG. And then geologist 2 start to compute, geologist 3, and then reverse compute. And then let's all go haywire. Wrong. And then if you learn about geodesy, there is also parameters, mathematic parameters about some some parameters in negative sign, some positive sign. So if you do it, if you switch it positive, negative, negative, positive, that will be another disaster. So it will skew the position. And then ellipsoid, and then so on, yeah? Datum, ellipsoid, and projection. Remember that. Datum, ellipsoid, and projection. That basically, when you combine it, become EPSG. So in the EPSG, there is all this information, metadata of that particular position. Okay, one of that. Another one is be extra careful on the geographical coordinates. So simplify the decimal places, guys. Because you start to simplify, you start to minimize the decimal places, and then that is where another error come in. The computation, if you do this computation, I challenge you, use the episg.io and then try to play around with that decimal place and see what the result is going to be. So, and then also the area west and east. So same coordinate, somebody write the west, and then the same coordinate also in east, but that location is in somewhere else. Yeah, and then feet to meters, meters to feet. So how many unit of measure do you know in the world? So if you go to Russia, if you go even in Malaysia, in Sabah, in Sarawak, in Sarawak, they still use feet. They still use feet. And then it's not in certain feet, it's the imperial feet, and it's called a Sears feet. So there is, if you compute that feet with the wrong factors, and you got the wrong position, right? Try to do that. See, let me tell you, 1 second of arc, latitude, longitude, yeah? 1 second of arc is approximately 30 meters, guys, on the equator. So kalau awak pandai nak, simplify the coordinate, so you are the one who make the errors. Meters, 1 second. So if you simplify it to half a minute, which is 30 seconds, it can be 900 meters, maybe more. Yeah, that's the errors I'm showing you. So do not round it up, else you will lose its accuracy. Okay, and then it's a little bit about, before I start. This is about dynamic CRS. This is another CRS, another coordinate reference that you have to understand. It's happening. So it's about dynamic CRS. I'm not going to show to. So you start.
Coordinate reference systems.
Sleep.
Hello, I am Roger Lott of the IOGP Geomatics Committee. Here is the movement of the Earth's tectonic plates over the past 100 million years. In this presentation, I will explain how this tectonic motion impacts positioning and spatial data management today. The various tectonic plates move at different speeds in different directions, and their movement of a few centimeters a year continues. We are zooming in to consider this plate movement in a human timescale. You can see a large-scale map showing a road junction with nearby buildings and lampposts. If you look to the left of the map, you can see the coordinates of one of these lampposts. The coordinates in black are reference to the CRS used by the GPS satellite navigation system WGS-84. WGS-84 is an Earth-fixed coordinate reference system. That is, it is fixed to the Earth as a whole rather than to any point on the surface of the Earth. From January 1994, WGS-84 has been aligned with Geodetic Sciences by TRS.
Sorry.
A few centimeters. The coordinates in blue are reference to GDA 94. an Australian coordinate reference system which is fixed to and moves along with the Australian landmass. GDA 94 was defined to be coincident with ITRF on the 1st of January 1994. So, in January 1994, because both GDA 94 and WGS 84 were coincident with the ITRF, the WGS 84 coordinates of the lamppost were the same as those in GDA 94. Now, as the years roll by, we can see the Australian plate and everything on it moving north-northeastwards at about 7.5 centimetres per year. The blue plate-fixed GDA 94 coordinates do not change. The Earth-fixed WGS 84 coordinates, now shown in red, are changing with time. Now this seems utterly bizarre. We know that Australia is moving, but the plate-fixed coordinates do not change. Meanwhile, the Earth-fixed coordinates are changing with time. Why is this? The perspective is that of you and me, stationary observers on the surface of the Earth. We do not feel the plate motion, but we are moving with the tectonic plate, along with the street, the lamppost and the plate-fixed coordinate reference system. Because they are all moving with us, we see no change to the GDA 94 coordinates. So we say that GDA 94 is a static coordinate reference system. But the tectonic plate and everything on it is moving slowly through the Earth-fixed WGS 84 coordinate space. The coordinates change, to us they seem dynamic, and so we say that WGS 84 is a dynamic coordinate reference system. So what does this mean? Coordinates referenced to a dynamic CRS such as WGS 84 are ambiguous unless they are qualified by a date. This is given as a coordinate epoch, a decimal number in the Gregorian calendar usually given to 2 decimal places. Coordinate epoch is an attribute of the coordinates, not of the CRS. But the CRS's description of whether it is dynamic or static informs us as to whether the coordinate epoch is required. Coordinates can be converted to another coordinate epoch to compensate for tectonic plate motion without any other properties of the dataset altering, and because of this, coordinate epoch is unlike other time-related metadata. It needs to be treated separately. Now this illustrates a problem that has emerged with coordinate reference systems. WGS 84 has been treated as if it were a static CRS because coordinate epoch has been ignored. This is not a problem at regional scales and low accuracies, but without correction it may not be tolerable for higher accuracy applications. What do we mean by high accuracy? We can define it as positioning in a dynamic coordinate reference system where the tectonic plate movement accumulated over the lifetime of the project cannot be ignored. Assuming a project life of say 30 to 40 years, and then depending upon the rate of movement of the relevant tectonic plate, the threshold for ignoring plate movement is between 1 and 3 meters. So if positioning errors of 1 to 3 meters are not significant, you can ignore time-dependent corrections of coordinates referenced to a dynamic CRS. But if you need accuracies of better than 3 meters, or are mapping at scales of larger than 1 to 10,000, then you must either use a static CRS or use a dynamic CRS and account for the change of coordinates with time. So why is this important? Let us have a look at an example using our earlier clip where you can now see 2 lampposts across the road from each other. The distance between them is calculated from their coordinates. You can see that in the static coordinate reference system GDA 94, shown in blue, this distance never changes with time. The distance is also correct in the dynamic coordinate reference system WGS 84, but only if you have the coordinates of both lampposts at the same coordinate epoch. It doesn't matter what that coordinate epoch is, could be 1994 in purple, or in 2020 in black, or at any other date. But, as shown in red, if you use the dynamic coordinate reference system for positioning objects at different times, and you ignore the change of coordinates with time, then the distance you calculate between the 2 locations will be in error. It will be in error by the amount of plate movement between the 2 dates. So remember, when dynamic coordinate reference systems are being used, geometric calculations are valid only when all coordinates have the same coordinate epoch. Ignoring this could have significant consequences. The oil industry has an expensive example when the bridge to be installed between an offshore platform built in the 1990s and an adjacent platform installed 20 years later did not fit. The old platform had been accurately positioned in WGS 84. Coordinates of the new proposed location were calculated, and the new platform installed at these coordinates. But during the installation, a surveyor using distance measuring equipment on the old platform claimed that the new platform was mispositioned. The surveyor on the installation barge insisted the new platform was within tolerance of the specified coordinates. Eventually, the argument was settled by an engineer using GPS on his mobile phone to confirm that the new platform had been correctly located. But when the prefabricated bridge was brought out to be installed, it did not fit. It did not fit because the WGS 84 coordinates on the old platform had not been corrected for 20 years of tectonic plate movement. With the downtime of the installation spread whilst the surveyors argued, and the subsequent delays to production, the cost of this incident ran into millions. Now let us consider some other aspects of dynamics that operate with...
Right. Stop this. Okay, I have to stop. I want what I want to tell is CRS is not unique. So based on what we have learned, what we have shared, I have shared earlier. So please remember this: CRS is not unique. So if you found something similar, so doesn't mean it's the same location. It can be a different location, and then errors can be created, and then that's it. Got problem with that later on. Right, in our GP, so we can see a lot of publication, learn from there. I am just show it to you a lot of that, and then last but not least, the solution. So what basically now people ask me, so Safa, what can be done then with all these errors? We're not going to repeat the errors. We're not going to repeat the same thing again. Now we know. So what is the now? Number one is client to provide computation example. So ask your client, whoever give you coordinates to convert, ask for a data example, right? Ask for data example and then use approved geodetic computation software. So I have shown you just now that is EPSG.io, and then you can browse more other software in the market around. Can't remember. I'm not going to market it over here because you can find it out. So approved geodetic computation software. One of them I already shown you, the geometric solution. They can provide that. Right, you can buy you can subscribe, you can buy the software. They are made in Malaysia basically, in collaboration with the office in Newcastle in the UK, and then training. So again I'm gonna repeat, ask client data example, use approved geodetic software, and then do a lot of training, a lot of exercises. Yeah. And then the software, as I said just now, is Geometric Solution. They provide the software. That software has been recognized or has been endorsed by IOGP and EPSG as well, because they provide that to EPSG and IOGP. So use the software. So this is their website. I'm going to play it. This is about 3 minutes, guys. No sound. So this is their website. Go and browse their website. And then, as I said, you can visit their office here in Kuala Lumpur. Give them a call, say that you want to visit them. Yeah. And then, so they are, some of them are locals. Right, I think one of them is your senior, I think, Yen. I think one of your UMT seniors. You can contact him, contact them. the locals. Yeah, that I think I don't know. Maybe yeah, and this is the owner. So go and talk to them and visit them. Right? Okay. And then conclusion. Last conclusion. Right, guys? This is my conclusion. Mark this, CRS is not unique. Reject. If you doubt the CRS without EPSG, reject it. So never, if unsure, find out. And then always ask the EPSG code. Yeah, ask the datum, ellipsoid projection, and unit or measure. And then some errors can be corrected, some don't. So now you know what is the impact. So don't be that guy, don't be the person that being blacklisted in the industry. So don't be that guy. Don't be the statistic. And error leads to reputation and cost. You saw that cost a lot and your reputation. So from that on, if you make mistake and then and then that's it. If you go somewhere else, people know you, and then people reject you. Unless if you do it, take time and do it right properly. Otherwise, you end up, maybe become a grab rider or something. Training make perfect. So do a lot of that computation. If you don't have the numbers, you can ask. You can ask, can request some test coordinate from Petronas, from Shell, from oil and gas company who has that. They keep this EPSG, yeah. They call it EPSG registry. So they have that. So you can do a lot of, not just for Malaysia, for other countries as well. Indonesia, Thailand, Vietnam, China, UK, That's it. That's the end of my presentation. So I guess thank you for your attention. I can't see you, I cannot hear you, but so you can ask questions. Let me go to the Q&A. How can I see your Q&A then? Is there any question there? Chat, in the chat. Yeah, just drop, a text. So this is my email address. You can send email, you can send, do not send your CV. Do not send your CV. Send your question, maybe you want to do internship, so I can consider that. I'm not going to promise anything, but it's good to accept you guys, but not so many, yeah, not one class, just a few guys for internship, just to show about not just the coordinate but other things as well, related to geology. Yeah. So any question? We have time. We have a lot of time. If you want me to repeat, if any slides that you think that you missed or you missed out, so let me know. I can go back to the slides, or else I just copy this presentation to Luqman, isn't it? Yeah, Luqman always is the person who. Yeah, Luqman Muhammad Zaki. Very quiet, I know.
Assalamualaikum Cik
So
Safa.
oh yeah, Aina.
Saya nak tanya,
Aina.
untuk yang CRS tadi tu, dia kan ada macam-macam,
Yeah, I
dia
think
kan ada
you are the
beberapa
one of
jenis kan?
the intern, right?
Ah, ya.
The incoming intern
Ah,
from UKM,
ya, yes.
I think.
Saya cuma nak tanya, dalam CRS tu dia ada
Right.
beberapa jenis kan?
Sorry.
Macam mana kita nak tahu kita nak kena guna CRS yang mana
69
satu
69
untuk mengikut kesesuaian?
Aina,
attendees,
tak boleh dengar, dia tak boleh dengar. Dia ada masalah speaker. Dia kena type dekat chat box.
So saya cuba nak tanya, okay, question from Aliba, Aina. Saya cuba nak tanya macam mana kita nak tahu penggunaan CRS yang mana satu yang sesuai. Okay, good question. Let me answer this way. Remember this. Client. You have to get it from the client. It's not from your project manager, it's not from your boss, it's from the client. So the client already has the best fit CRS for the project. From the day one, they decide to explore land or offshore. From the day one, they decide to explore that location, they already engage a geodesist, remember this, geodesist, to advise them the correct CRS. It's not you, it's the client. So if you don't see the CRS from any sources, yeah, from your office, from your friend, from your colleagues, from your bosses, if you don't see, again, I'm repeating again, if you don't see that EPSG code with that coordinate CRS given, reject it. Get it from whoever give the coordinate to you. That's it. So they should give you with the coordinates and a test, and then all the coordinate reference system, the datum, the ellipsoid, and all that. So they should give you a number of that, and then you can check at epsg.io. You key in the number of EPSG, then you can see the whole background of that CRS. Then you will be safe. I hope I answered that question, Aina. And for the rest. Yeah? Good question. Oh, Mahathir. Ya, sebelum saya intern, ada berapa subjek yang perlu kami ambil? Tak, macam specifically subjek berkaitan CRS ni. I don't know. I have no idea what is in your program, content of your program. But for our THS Geoscience, for our intern, I already feed them with a lot of say like YouTube link, some PDF documentation about CRS, about this about the subject. So not just becoming an intern, but it's becoming a good geologist. So as one geologist, when I was with this national oil company, they have to attend the CRS classes. So I was the one who conduct the training, not say training, but sharing, just like you guys. But the only thing is, it takes about 2-3 days. So the third day, I have like a data example for them to calculate, for them to appreciate. So if I simplify the decimal places, what will happen to the converted coordinates, So if I do it wrong, east and west, or north and south, do you know that Indonesia, if you have project in Indonesia is a southern equator, so it's not north anymore. It's a south. It's all south. But certain grid system, they don't like south. So they're going to allow false noding. Yeah, false noding, something like 10 million false noding, so that coordinate become all become positive, all become north, yeah, but north from this false noding. Okay, this guy, when I show, I still the same thing. I told the same thing. If no EPSG, don't accept it. So one project, they drill, they have start drill 210 meters away from the location. They don't know that. But this guy who has attended the training, attended the class, knows that something wrong with the coordinate, because that coordinate doesn't come with EPSG code. Doesn't come with all those of the data of the coordinates. And then something wrong somewhere, and then they drill at the wrong location 210 meters away. Then that drilling program is a vertical drilling. So because of that, they already drilled 210 meters away. So they have to change the program, because they're not going to move the rig 200 meters to the right location, because they're already done. They already start drilling. So they have to change the drilling program, become a directional drilling program, and that costs a lot. Yeah. So don't do that. I'm telling you now, because when you start working, and then you will be busy like crazy, and then you don't see that EPSG code anymore, and then that coordinate just pass through your desk, and then go somewhere else, go offshore, and then somebody use that coordinate and then start drilling, and then drilling at the wrong location. Nice geology, very positive geology, but at the wrong location. So it's just like a waste of time and waste of money. All right, from Aidil Imran, are there any EPSG codes specifically designed for deep subsurface geology, mining application? Where can I find it? In the EPSG. Yes, in the EPSG. So they have that. So if you go browsing the Geometric Solution website, if you go to EPSG IOGP website, you can see this. So it's a matter. It's a deep subsurface geology. It starts from the top, So they know. So if they want to drill there, if it's a vertical drilling program, so it will start from the right position on the seabed, on the surface of the seabed, and then straight to the target in your deep subsurface. So it can be, it can be vertical drilling. It can be we call it deviation drilling. or something like that. So there is a PSG code for that. Look for it in the website. Learn from it. So yeah, right. So I hope I answer the question. And then Lukman, saya nak tanya based on pengalaman, berapakah gaji average untuk CRS expert or surveyor untuk offshore? Oh, okay, macam ni Lukman. There is satu position. There's one position they call it. It's not surveyors anymore. They call it geodesists. Right? So geodesists is very rare in Malaysia. I can only see few geodesists in Malaysia understand about this, yeah, becoming a consultant about this. Some of it or somewhere in the university become a doctor or PhD with, become professor or Professor Madya somewhere, right? But average gaji, I don't know. Because if you are a lecturer, if you are a geoscientist, if you are geodesist, it depends on how well you attend to the problem, into the world geodesist problem. So it can be like 20,000-30,000 ringgit, maybe 50,000 ringgit if you not just be there to consult the client, to consult the geophysicists, geologists, but you consult everywhere in the world. So do not talk about gaji anymore. You talk about how to set up a company. Yeah. So it's not gaji anymore. It is basically a company. You can build a geodesist company who a very reputable company that can handle geodesy. Yeah. So you set your own gaji lah. Right? In US dollar ke euro ke whatever it is. Right, Aidil? Sorry, Lokman. I answer your question. So go and learn geodesy. Apply it to your geologies and then learn about it at master's and PhD level. You can be geodesist. Right? Not you say that you're geodesist, but the industry will regard you or will call you. Once in a while you go to conferences, seminar, and then maybe a talk to somewhere else and in this region, maybe outside, because you are the expert of that. For example, just like just now, the dynamic CRS is the new. We don't have it here, but we have somewhere else. Yeah, we have the issue somewhere else, and then it needs somebody with a geodesy background that is proven the capability, the knowledge to advise the client what to do with that, where to get that information from, how to compute the dynamic transformation, the dynamic CRS. So you will be paid for that, inshallah. Yeah. So you have time to become the expert, inshallah. Okay, Lukman. So don't just stay at this level. Go further. Yeah, become an expert on that, inshallah. I hope the rest. I know you're listening. I know you are okay. Ideal. As geology students, we are passionate about our field, but we sometimes hear concern about its future relevance and career opportunities. From your perspective, does geology, geodesy, geometric have a broad opportunities in that? Oh yes, of course. Every year, say, look, man, Ideal. Every year, a lot of old people resigning. A lot of people pension. Retiring, and then a lot of these expert become away from the industry, and then they so you are the young generation, I don't know, Gen Z or Gen Z X, like whatever, I don't know. But you are the one who's going to replace them. So why not? So from your perspective, yes, have a broad opportunities in the next few years. In the next few years, you become the expert. Do masters and PhD and learn about it. Go to the field, not just become the theory guy, with all the formulas and all in the head, but you must also be outside there and then fix people problem. Yeah, just like Tony Fernandez. So solve the air travel problem. So you are the one who solved the geodesy problem with the geology. And what are the skills or mastery that we have to obtain in order to stay competitive? Learn, train, relevant and evolved job market. So I'm showing you now. So if you combine with your geology and then geodesy and further with that, so understanding, and then same time work. So we can work at the seismic company. Seismic are the land seismic, and then you have marine seismic, right? And then you have various type of seismic, on bottom seismic, cable to seismic, and then land seismic, and learn from the start. So if you learn from the start, making the seismic survey at the right location, and then you can see, because of the right location, you can see and then a nice 3D, 4D product of your geology interpretation, geology analysis, and then you become the expert in the next 5 to 10 years. You must have that plan then. It's not now, and then the next day you apply, and then after that you got 20,000 ringgit of salary. I don't think so. You have to start from scratch. Show that what you can do. Right? There's a skill, I think, if you try to relate geology, geodesy, and geomatics and same time. So geomatic, you don't have to learn all those land survey technique, Focus at geodesy. Go and learn geodesy. There's a very thick book about geodesy, very thick book about all the mathematics related to geodesy. Yeah, it's a long question. I think it's a long answer. Huh? I hope I answered that ideal. And for the rest of the participant, still there? 66 still there? I have a feeling that you guys must visit this company, visit the geodesy company, yeah, geodesy. I'm not sure. I'm Malaysia. I can only recommend Geomatic Solution in KL. Go to the website and then see what they can, even you can request for a trial of their software if you like. And then of course, my company also provide some positioning, computation and all that. But yeah, you can come, you can visit. I welcome, but don't come in one bus, because in one big UMT bus, because my office is small in Kajang. But you can come. I welcome you guys. Please come and then have a chit chat, coffee after Raya. Inshallah. Yeah. So bring your friends and then come and have a discussion, more discussion. Inshallah. Yeah. If you like, geodesy is the way. In the moment, I can feel that. Anything else? I see a lot of other. Hang on. Oh, ideal again. I hope this question is from other than ideal. Okay, last but not least, can you give motivation to us geology students, especially to keep pushing forward despite all the concern? We got some first year student in this meeting and they would love some motivation to keep striking forward. You see, your geology, your scope of study at UMT, I have no idea. I have no information about what you learn and where is your direction of marine or applied geology, marine geology, or I'm not sure. Can you give me a little bit of hint what have we learned? Because I'm thinking about hang on, because in USM, University of Science Malaysia, they have a geophysicist, no? But still somehow it's not. I don't remember if there's a connection between geology and geometric. As I mentioned just now, it's about location, it's about geodesy. So why don't you go and learn a little bit more understanding about geodesy? So what can go wrong? What went wrong and what can go wrong if the geodesy is wrong? So you have a set, for example, you have a set of geology data, you know, nice traces, nice layer of geology. Then if you know that the data is lack of geodesy accuracy, then find out what happened if we do it right. I don't know. Maybe much more. I can't think at the moment, to be honest. But they all, as I mentioned, there are every year senior geology somewhere, Jabatan Mineral and Geoscience or Petronas are aging. They are aging, just like me. I'm aging. I'm 60 years old. Aging means they are going away and away from there, and then the new breed coming in. So if you learn something directly or indirectly, you know, through contractors, do not berharap, you know, do not hope that you're going to work with the national oil and gas or, you know, international oil and gas. You can work through their contractors. I think their contractors much more quantity is more than themselves, because oil and gas they don't do the work themselves. They contract the work outside to contractors, to the expert. So if they know that you are one of the you know, start for the first year. Hang on, for the first year. For first year student, start your topic. Start to choose. Start to not just choose, but start to prepare your final year project from now. Not towards the last 2-3 semester before you graduate. You start to choose the topic now. Talk to your lecturer, talk to your supervisor now, right? And then maybe you can start roaming around and go and see the you know, oil and gas company, correspond with them, email them, you know, WhatsApp them, say that, you know, what if you have, see, sometimes a good topic come from a problem happen in their company. You know that, right? So they have a problem in the company, and then they want somebody to solve it, somebody to find a solution. And then if you keep contacting them, and they say, hey, Ideal, go geologist then. Hey, I think my company got this problem. Do you know that, you know, somebody can advise you? I'm not really remember what we can do. And then you start finding the solution. Yeah, that can become your final year project. It's a real work. Why not? This is what happened in Europe, in the US, in the Europe, because academic, yeah, universities and industry link together. They link so close. So just like, you know, you graduate today, tomorrow you start work. So think about that. Don't stay. Don't. What should I say? Not to behave like student. Do not behave like a student. You know, you have enough time until Form 5. Now you are at university level, and then you have only 3 or 4 or 5 years for you to prepare to go and work in the real world out there. A world with especially geology. Now in Japan, in Taiwan, they're busy with the wind farm. They're busy with wind farm. Go and find out about wind farm in Taiwan, in China, in Japan. And then maybe you are one of the geologists going to work there, and then start understanding about what their problem. Okay, I have a geology problem. What can you think about? What can you assess? What can you what into your study? I don't know. So I can see a lot of future geologists there. Go. Start link with the world. I know you have a lot of assignment to do, but you know, assignment, you can't show your assignment to your future employer. Huh? I've done this assignment. I got A 100%. No, but that's not solve your employer problem. I hope I give you a little bit motivation for the first year student. I hope. Am I? I see no response. Yeah, I see a lot of Zeti, Wong Po Yi, Wan Nur Ain, Teo, Tin Cher, Tan Wen Hui, Niam, Sri, who else? Rose, Tan Chong Yuan, Priyanga, Niranjana, Maliana, Kishore, Irdina, Izzati, Akram, Andy Ting, Chun Chen Ping. Yeah. So in Taiwan, there's a lot of wind farm project. Huh? So they all got to do with geology. So how are they going to study the geology, surveying, mapping, interpreting, and then decide where to drill and where to put the if it's safe to install the platform there, install the wind farm there. It's a lot. Taiwan, Japan. If you don't want to go far away, just here. Taiwan, Japan. I'm not sure. Hong Kong, I'm not sure. That's a lot. As you can see just now, yeah. So we are moving. Huh? Our plate tectonic is moving. So become that expert. Huh? A lot of money. Not just a lot of. You can set up your own business in 5 years, 10 years time. Millions. And come back to UMT and share. Right? And then get few interns from your UMT. So it goes around and around, you know. What goes around comes around. So if you do good things, and then it'll come back to you. So inshallah. Okay, I think it's about time to leave, huh? It's Lokman. Lokman, I got to stop. Oh, photography session. How are you going to do that? Switch on. Hang on. I need to make up. I need to do a little bit of lipstick and powder. Hang on.
So, yang lain semua boleh on camera, boleh pasang background. Kalau malas pasang background, boleh on camera je lah.
Okay. Where are you guys? Alamak, tak nampak agak. Hang on. Right. Okay. I'm ready. When you're ready.
Okay.
Oh, Lukman, nanti whoever record this, so can we trade? Can we trade? Can we trade? I trade with my presentation, you trade with the recorded, okay? Let's do the trading. Win-win. Recording on YouTube. My goodness. Let's go into. Right.
Okay, multimedia. Multimedia ready.
Thank you for listening anyway. Thank you for the question. So I'm not sure if I'm going to share the same thing again. In the UNT, same topic, I'm not the same topic. Because you're recording, right? So we can replay that anytime. So
lagi nak on camera.
Buy me nasi dagang.
Okay, ready. 1, 2, 3. Screenshot je. Multimedia screenshot je. Screenshot. Okay, last one. 1, 2, 3.
Okay.
Okay, with that, we have reached the end of GEOTALK 4.0. On behalf of Geoscience Club, myself as the president of Geoscience Club UMT, I would like to express our deepest gratitude to Mr. No Safaruddin, even though he cannot hear us, for his valuable time and knowledge. We also appreciate all the participants for joining and making this section a success. We hope this talk has been beneficial to everyone, and stay tuned for more exciting programs from Geoscience Club UMT. Till we meet again, thank you and Assalamualaikum warahmatullahi wabarakatuh.
Right, all the best. All the best. And you got my email, so we can start linking with the industry, guys. Don't stay in silo. Yeah. So, okay. So I'll be I'll be here. Thank you so much. And Roger and out from Putrajaya. Okay. All the best from Putrajaya. Bye.